So for problem number 19, what we're going to do is more of the same. It says if it takes 400 joules of work, Problem number 19 says if it takes 400 joules of work to stretch a spring 8 centimeters. What's that?
That's
0.08 meters.
Very good. What's the spring constant?
We don't know that.
All right, so I like to say this, and I say it about 3 or 4 different ways, but I just want you guys to observe what I'm doing. As I'm reading the problem, the first thing I'm going to do usually is I'll read it, and steps 1 through 3 are interchangeable. You can do them at the same time. I'll read the problem. I'll usually draw a picture. I will also label what I know. And then the next thing is I figure out what I need to know. This is it. Boom. So as I was reading the problem, I did all 4 of those steps, except for draw the picture. So now I'm going to come back and draw the picture. So I have an object that's connected to a spring, perfectly drawn spring. And to move this thing 0.08 meters, I've done 400 joules of work. The next step in this process, there's probably an equation that'll help me find what I need to know based on what I already know. Is there an equation that has work, the spring constant, and x in it?
Work equals 1/2 kx squared.
Work equals 1/2 times k times x squared. I am looking for k, so what I'm going to do is I'm going to multiply by 2, so I've got 2w kx squared, then divide by kx squared, so I end up with 2w x squared is equal to k. Is that right?
Yeah.
All right. Sorry, it looks a little sloppy there. So now to solve for that, 2 times the work is 400 joules all over 0.08 squared. And then I think, let me look at my notes here. Yeah, that's right. So now what is that going to equal when you're done?
1.25 times 10 to the 5th newtons.
1.25 times 10 to the 5th newtons. I like how you said newtons per meter.
Is that right?
Yep,
Yay.
the units are important.